All right, so hello there. This is Mr. Frazier, and we're in the last section of this book. It is 10:7. Okay, and here we're talking about areas of circles. Okay, areas of circles. Okay, and then we're going to talk about sectors, segments, triangles in the circle. One of the big concepts in this section is understanding that when you have shapes inside of other shapes, you're going to use the operation of subtraction in order to get to the answers that you're looking for. Like you're going to have to subtract some things from other things so that you can find pieces. Okay, so let's talk about circles to begin with. Hopefully we know circles are 360 degrees. And again, you're going to have to use like proportions to be able to find out certain pieces of the circle. All right, so the formula for the area of a circle is pi r squared. Pretty basic. Okay, it revolves around the radius again. And understanding that finding the area of the circle is never too hard. Then we have something called a sector. And a sector is this piece. Okay, it's a piece of the circle. Okay, or a percentage of the circle. So, for example, if you had a 90-degree angle here, you know that's how much of the circle. Let's see, we'll do 90 over 360, and you know that's 1/4. Okay, so it's 1/4 a circle. So whatever the area would be, if you divided it by 4, you'd find the area. All right, and when we did the length, we put the circumference on the bottom. So when we're doing the area, we put the area formula on the bottom. So this formula is used a lot. I'll put a degree over 360 because that's still in the bottom, equals, and then you're looking for a piece, which is usually x, and pi r squared. Okay. So you would use the area formula here. You're going to have a degree measurement from 360 degrees. We're going to cross multiply and solve. All right, easy enough. So finding a sector is pretty simple. It's the area of the circle, and then whatever the degree is, you're finding that percentage. That's the easy part. Okay, so now we have a different diagram. Okay, and I'm going to talk about a different piece, and it's going to be right here. Okay, now here's where we get a little tricky. You have a triangle, and you'd have to do triangle work to find that one. Okay, and then you have this piece right here. Okay, now that piece is between the circle and the triangle. That's called a segment. Okay, that's called a segment. So you've got sector, then you have segments, then of course you're going to have triangles. Okay, so now we're going to find some other things. If I'm trying to find a segment, I would have to subtract out the triangle from the sector. Okay, notice I'd need the sector minus the triangle, and I would find the segment. If I'm looking for everything else, I'm going to subtract out the segment. Now, this ends up being one huge problem. Why? Because it ends up involving everything we've done and following some very specific steps. All right, so let's do a basic problem. Okay, one of the basic problems would be, let's find the area of a circle. Okay, so simple enough. Let's find the area. Okay, so I'm going to draw a circle. Okay, I gave you a measurement. The first thing you want to do is you would write area equals pi r squared. I'd find the radius. Hopefully you know the radius. Excuse me. I apologize. The radius would be, correct, 6.5. So it would be pi 6.5 squared. We would use our calculators. And remember, the nice thing about the calculator is it does it for pi with you. So it would be 6.5 squared pi. You end up with 132.73. In terms of pi, it's 169 pi over 4. Okay? So again, you use this, it toggles back and forth between and pi. So the area is 169 pi over 4, or approximately 132.7 units squared. All right, easy enough. Finding area problems, not too hard. Now we're going to do a sector of a circle. We're going to find the sector. So I'm going to draw a circle again. I'm going to give you some measurements. Okay, so here we have the circle, and I'll give you some measurements. Okay, we'll do this. I'll say this is 72 degrees, and this is 15 meters. All right, so here we go. I'm looking for the area of the sector. So that's 72 degrees over 360 degrees. Okay, now why do I know I'm doing that? Because I'm finding the area of the sector. Okay, so that's the percentage of the circle. 72 degrees of 360 gives me the percentage of the circle. And then I'm looking for the sector, so that's across from my 72. And then the whole circle is pi r squared, and in this case it'd be pi 15 squared. All right. So, hopefully you understand that when we cross multiply, you get 360x equals, and then you do 72 times 15 squared pi, which is 16,200 pi. Okay, you type it right into your calculator. See how it comes out. Okay. And then you would divide by 360, and you get 45 pi. So that is the area, 45 pi meters squared is the area of the sector. This would be the area of the circle. Okay, and we're looking for 72 degrees of 360, which would be 45 pi of the 1620. All right, good so far. So we've been able to find the area of the circle, and then using that formula, we've been able to use it to find the area of a sector. Okay, so we're going to move forward. Like I said, this gets a little bit more complex. So now we have the area of a triangle or the area of a segment. Okay, so if I was finding the area of the triangle, then I just find the area of the triangle, which means I would just draw the circle, draw the triangle, find the area. If I'm trying to find the area, of the segment, it's now the circle minus, or excuse me, the segment, or God, I'm getting all the words mixed up. I apologize. It's the sector. So here we go. I'm drawing this, and I'm telling you this is 60 degrees, okay, and this is 18 inches. So here we go, and they want me to find this area. Of course, we know that's called a segment. So that is the area of the sector minus the area of the triangle, of that triangle, and that will give me the crust. I like to call it the pizza crust, okay? So I can find the pizza crust, but what I have to do is I find the area of the sector first, which is my proportion work, get an answer, subtract the area of the triangle, which I'm going to do some triangle work, get an answer, and when I subtract those two, I will have the area of the segment. So let's see where we begin with the problem. First, I would draw the original picture. So here's my original picture. I first draw the original picture, and I would draw it so that the triangle was down, just because I'm used to it. So this is 60 degrees. Okay, and then right next to it, I would draw my triangle work. And I'd put in the measurement, 60 degrees. Now, here's the thing. If I know that's 60, what do the other two have to be? They also have to be 60. Now, in this triangle, it happens to be that because I know the radiuses are always the same, which means I end up with what kind of a triangle? An equiangular triangle, as well as an equilateral. All right, and you got your 30, 60, 90s. Now, how they make this tough? They don't put 60. They use some weird measurement, and then you might have to use sine, cosine, tangent. But right now, I find the area of that sector. So first I drew the picture, the original, and I find the area of the sector, which would be 60 over 360 equals x over pi 18 squared. Okay, so I'm finding the area of the sector first. That would be the whole thing, the entire pizza slice. Then I'm going to eat the pizza and leave the crust. All right, so I cross multiply and solve, and you keep it in terms of pi. Please keep it in terms of pi. So you do 18 squared pi times 60, and then divide it by 360, and you end up with 54 pi. So here's one of my numbers, 54 pi. And I know the next thing is going to be minus, because I got to minus the triangle. So now I'm doing triangle work. And as I'm looking for that altitude, because the area of a triangle is 1/2 base times height. Now, I know the base is 18. Why? Correct. I know the base is 18 because the radius is 18, and if it's equiangular in a triangle, it's also equilateral. So 18, 18, 18, 18, 18. Okay, so the base is 18, so I have 1/2 18, and I just need the height. Now the height is right here. I know this side is 18, and when I go down, I know the altitude that I drew. I didn't draw an apothem. Now you could have, but you're going to make it harder on yourself. I drew an altitude this time, and I just did the area of the triangle. And I split this side to 9 and 9. Okay, I have two sides of the right triangle. I can use Pythagorean theorem to find this altitude, or, otherwise known as height. I know if I go up, it's 9 times the square root of 3, right? So I do all that in the calculator. Now I'm telling you I don't need to because I can do most of this in my head. So half of 18 is 9. 9 times 9 is 81. This would be 81 square root of 3 equals. Now, this is the math problem you put in your calculator. So 54 pi minus 81 square root of 3, and you get 29.34. Okay? In this case, it would be approximately 29.3 units squared. So again, finding the area of the sector, that's that work. Then the right triangle work, or the work for the triangle, 1/2 base times height, area, minus the 2, and that will give me the crust, or the segment. All right, well, I wish you good luck. This is the last section in this chapter, and then we're ready for the test. All right, have a good day and good weekend, and study hard and do well in class tomorrow, and hopefully you study over the weekend and we come and do really, really well on this test.